Hello everyone, my name is Fatima Belok. I will present today a research having a title Digital Framework to Optimize Visual Comfort Using Kinetic Facade. The aim of this research is optimizing visual comfort in educational spaces using responsive kinetic scan. Through developing an add-on on a plugin, a digital tool that will be utilized to optimize visual comfort through a graphical user interface GUI that is user-friendly to architect. So the aim and the objective is to optimize visual comfort by using and creating a new add-on plugin, which is a digital tool. The research will focus on visual comfort. The visual comfort have different parameters. The selected parameters here are illuminance and glare, which are based on European standards EN, are two of the most important parameters. Here is an example of the illuminance, which has colors that range from red to blue, from high to low illuminance, and here is an example of a glare illustrated as a camera view. The visual comfort here is achieved through kinetic scans and applied to educational spaces, especially university library. There are different simulation programs for doing environmental simulations. Here, the used plugins are Ladybug and Honeybee. Ladybug and Honeybee are plugins in Grasshopper 3D for Rhino. So, various plugins in this field have examined to create a framework that will help to develop an add-on plugin for optimizing daylight comfort in educational spaces using kinetic facades. But before digitalizing this add-on, an add-on framework is created. This framework is composed of three phases. The first phase is the input phase, the second phase is optimization, and this third is output. The input phase contains the weather file, the date and time, the dimension, the kinetic shading model. The optimization phase is divided into two phases, the illuminance condition and the glare condition, which are the two selected factors. Then a comparison between the two conditions is done to say if this case is optimum or not. And the output phases will have different output that will be mentioned later on. Here is a detailed add-on framework including input, operation, and output. In the input, we have fixed parameter and variable parameter. For example, in the optimization, we could specify one of the variable parameter. Let's say the motion of the kinetic facade. Let's say we have selected the rotation, and you have specified some angles, 13, 16, and 19. Then we should specify the time, the hour, the day, and the month. Then the optimization and the process will work to give us the phase number 3, which are the outputs. Also, the inputs are divided into two ASCAAD, fixed and variable. I have divided them, the fixed, into three phases also. The environmental parameters, which include weather and orientation, the architecture space parameter that include the area, the furniture, and the function, and the kinetic parameter, which are the geometry of the kinetic facade, the speed, and the mass. And the variable parameter include the motion, time, and simulation. Now the framework is digitalized. It is transformed to the computer and the scripting has started. So as we can see, the phase of input are now digitalized. The phase of optimization is the same. It contains two conditions for the illuminance and for the glare. And the outputs, we can see it as illustration. How the framework is digitalized. The framework is digitalized by using the script. The script, I mean by script, the coding. For the coding, I have used Python and Grasshopper to create code for different scripts. We have created 7 different scripts. these seven different scripts, each one is responsible to do something in the new plugin. For example, the script number 1 is for selecting the simulation types. Script number 2, angle and value. 3, animation value, slider value. 4, date. 5, illuminance target. 6, illuminance condition. And 7, optimization condition. Here is just one example of how the script has been created. Now, the user of the created add-on will not interact with all the complicated scripts mentioned before. For that, I compiled and clustered all these scripts together in a few components having a friendly graphical user interface to facilitate the interaction with the user graphically, especially if they are not expert in environmental simulation tool. So a new add-on is created here called Kinetic Proposed Add-on, as we can see it here. And this Kinetic Proposed Add-on is composed from different components. So this is the Kinetic Proposed Add-on. It's composed from different components. Each component is explained here. It's for certain targets. Now, we have done an application in Lebanon, specifically in Tripoli on BAU University for the library. Also, a kinetic shading system is created. This is the design selected one. This design, by the way, I have done it as a physical model, real physical model using foam boards and motors and gears. And I have worked it as a real physical model to make sure it's working. And this is the space. So now we can see the results of the testing. Here are the glare results, and here are the illuminance results. All the results for all the cases are seen here. We have also created like a formula. We can see here numbers 0 and 1. So if the equation have a number equal to 0, so the result mean it's not optimum. If it's equal to 1, mean it's optimum. And these are also illustrated graphically. So as output, we have different graphs such as the optimum angles, and we have also the glare graph, and we have the illuminance graph. Now, as conclusion, after comparing the result before and after using the add-on, so to see what are the added value of the created add-on, I have done a simulation using the existing plugin and using the new plugin. We have remarked some added value. For example, we can now see when the results are optimum or not. Also, we can see all the results at the same time, so we can do a comparison between glare and illuminance. Also, a friendly add-on graphical user interface is a cluster and reduce lots of steps. As you can see here, lots of steps are reduced. And we can run at the same time illuminance and the glare. Before creating the plugin, we should run each one by itself. We cannot run both of them at the same time. Also, one of the most important was that the time is reduced to the half, so 50%. For example, it was taking 10 minutes, now it's taking just 5 minutes. Also, we have ability to save all of the simulation results graphically and numerically in external files. And the simulation could be done not just in educational space, also in offices and in workable space. So consequently, this will facilitate the architect ability to realize more effective kinetic skin mechanism and to optimize visual comfort in various spaces, which will be automatically improve performance and the productivity. As recommendation, it's recommended to extend the use of the proposed add-on to other type of function beside educational area, expand the add-on to include all form of kinetic system, not simply the rotation, and expand the add-on to accommodate more visual comfort characteristic beside the glare and illuminance. Here is a simple video made for the simulation. This is the University of Beirut Arab University and the selected space. We have selected the library, and I have here explained the add-on, how it's made. Here is the digitalization of the add-on. For example, we could here do the modeling for the kinetic system for the building. Here we could done the weather file, and we could integrate and put all the data like the list of hours, of days, and of angles, and we could run the simulation. Here are the condition number 1 and condition number 2, and how the comparison is done between themselves. Also, here are the results that appear as graphs and sheet Excel. Here is the testing and the performance. We can see here the eliminance. Also, we can see the glare results of the library. And that's it. Thank you, and thank you for watching.